Okay, now continuing with compound interest, what if it says compounded continuously? So not monthly or daily or quarterly, but it says continuously. Well, this is our key or indicator that we're going to use PERT. So P-E-R-T. So E, remember this is that natural number E, kind of like the natural log, which is log base E, similar to pi. So it's a natural number and it's found in your calculator. And what we're going to do is use this to go ahead and do our calculations. So it's going to be very similar. So same two problems. Let's look at some of the differences here. So how much will you have at the end of 3 years if you invested $10,000? But in this case, we want to take this off, and we want to say compounded continuously. So what if this said continuously? So compounded continuously at 12% interest. And so we're going to use PERT. So how much would I have if I started with $10,000 times E, which is that natural number, raised to my interest rate, which is 0.12, for 3 years, so times 3. And so when we plug this in our calculator, we're going to hit 10,000 times second ln brings up E, and we want to use parentheses in our exponent, so 0.12 times 3. So after 3 years, this should be $14,333.29. So anytime we deal with money, we go to 2 decimal places. Now, what about this? So again, instead of compounded monthly, we're talking continuously. And if I'm compounding continuously at 6%, so I'm going to start with $3,000 times E raised to my interest rate, which is 0.06, times 30 years. So after 30 years, compounding continuously, what would I have? So in my calculator, 3,000 times second natural log to get E, and raised to, I want to use parentheses in the exponent, 0.06 times 30 years. And so after 30 years, this would be a little bit more, and it would be $18,148.94. So maybe not much of a difference, but over time it would be better. So if you had the choice of something being compounded continuously, then you would prefer that over compounded quarterly or daily or monthly.